Now that we know our end behavior of our polynomials, we're going to look at the behavior of our roots. So we've talked about in class what happens if we have a repeated root. That root has a multiplicity. So what we're going to look at is what happens and how that changes the behavior at each root on the graph. So if we come in here, we have our factors. All right, we'll start over here at x plus 2. This is my factor vocab word. X plus 2 is a factor, but that gives me a root or a 0 at -2. That means my graph is crossing the x-axis at -2. And it only happens once because there's just a power of 1 there. Remember, if there's nothing written, that's a power of 1. So this happens once, so it is just going to act like a line. So we call that a cross. So if it happens once, it's going to look similar to a line. It's just crossing. Here, x minus 3, this again is my factor, and my root or 0 is at positive 3. X equals 3. So again, from our factors, we can see our roots. This time, it happens 3 times, which means it's going to buckle similar to my cubic function. So it's going to be like an x cubed. We're going to see it have this buckle behavior at that root. In here, my factor is x squared. It's giving me a root of 0. Okay? So it happens twice because of the squared, and that is going to go ahead and bounce like a quadratic. So if we have an x squared, we're going to see it bounce like this. All right. Second thing that we need to look at, now that we know how each root is acting on the graph, we need to find that end behavior. So if we take a look, if this root happens twice, this one happens 3 times, and this one happens once, I have 1, 2, 3, 4, 5, 6 answers, which means that my quadratic, or my polynomial, at its minimum, is going to be an x to the 6th. Okay? If we were to take x squared, x minus 3 cubed, and x plus 2 and distribute it together, multiply it all together, our highest power is going to be an x to the 6th. Okay? That's helpful because that tells me my end behavior. Because it's an x to the 6th, it's going to act like a quadratic. And it's a positive x to the 6th. So what we're going to see here is our end behavior. As x approaches infinity, y is going to approach infinity, meaning up. As x approaches negative infinity, y is approaching infinity. Again, up. We're going to see that up behavior. So we can go ahead and we can sketch our polynomial. Okay, 1, 2, 3, 4. 1, 2, 3, 4. So what I'm going to do is I'm going to put my zeros on the graph. So we have 0, 3, and -2. These are the only places that I can cross the x-axis. They are my only roots, my only zeros. So that's the only time I can cross. So to graph this, I know that I'm going to start from positive infinity, and I'm going to end at positive infinity. Okay? Those two tell me the direction I'm going to start from. And now I can sketch my graph. So if I'm above the x-axis and I come to my first 0, which is at -2, -2 happens once, so it is just going to cross the x-axis. It acts like a line. Okay? Then now I'm below the x-axis and I get to my 0. At 0 it happens twice, so it's going to bounce like a quadratic. But since I'm below the x-axis, I'm going to bounce below like this. I'm still below the x-axis and I get to my third 0, which is 3. And now at 3, this happens 3 times, so it's going to buckle like this. So all I've got to do now is come in and just kind of connect my points, And there's a sketch of that polynomial. Going to infinity, cross, bounce, and a buckle. Okay? All right, so we're already at 5 minutes, but I'm going to go ahead and I'm going to work through a second example just so we can see it. Make sure we're feeling okay. All right. So one more quick example. We're going to look at f of x equals x plus 4 cubed times x minus 2 squared times x minus 5 to the 4th. All right, so we could start by just looking at each individual zero. So here my factor is x plus 4, which gives me a root of negative 4. And it happens 3 times, so this is going to go ahead and buckle. Here at x minus 2, that gives me a root of 2, and it happens twice, so it's going to bounce. And here at x minus 5, that's going to give me an x equals 5. It happens 4 times, which is even, so it's going to bounce like a quadratic. All right, so now I need to know my end behavior. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 answers. So this is going to be an x to the 9th. So that tells me it's going to act like a cubic. So as x approaches infinity, y is going to approach positive infinity. And as x approaches negative infinity, y is also going to approach negative infinity. That's just giving me this as my end behavior. So let's go ahead and sketch that out. So got my graph here. First thing I'm going to do is I'm going to go in and I'm going to put those zeros in there. So I have a 0 at negative 4, I have a 0 at 2, and a 0 at 5. My end behavior, I know I'm down here at negative infinity, and I'm going to end going to infinity. Because it's an x to the 9th, we're going in opposite directions. Starting negative, ending positive. So here at negative 4, it happens 3 times, so it's going to buckle. I'm below the x-axis, so I'm going to cross like this. Now I'm above the x-axis, and my next 0 is 2. It happens twice, so I'm going to bounce, and I'm above the x-axis, so it looks like this. I'm still above the x-axis, and I get to 5. 5 happens 4 times, so it bounces. So it looks like this. And I can come in and connect, and here's a sketch of that polynomial. We have a buckle, bounce, bounce. As x goes to negative infinity, y goes to negative infinity. As x goes to infinity, y goes to infinity. All right. Take a look at those. Use these examples to help you sketch. Let me know if you have any questions.